Hi everyone, I am Ibrahim Barış Kula, molecular biology and genetics students at Bilkent University. Today we will find the kinetic and static friction coefficient between wooden block and aluminum surface. Let's come to the lab. As our materials, we have 50 cm long aluminum foil, 1 and 5 newtons of 2 force gauges, and a small wooden block. There has to be hook or ring attached to it. Remember that aluminum foil is very thin and can break very easily, so treat gently. Also, it has also two different sides, the slippery side and less slippery side. We will use less slippery side, and you should use only one side of the block through the experiment. Every side is not sanded equally. We are finding the weight of the block now. We hang the block with 5 Newton force gauge. Note that the result is not mass, so we don't have to multiply it with gravitational acceleration to find the normal force. Now we are finding the static friction coefficient. We pull the block with our 1 Newton force gauge perpendicular to it. If it is not perpendicular, it will create error. Minimum force that makes the block move is maximum static friction force. I do the pulling 3 times and will take the average of it. Let's find the kinetic friction coefficient. Our rod is 20 cm long, but we don't want to static friction to involve our experiment. So we will put the object a bit far from the start line. Do not put it so far because we don't want to create a velocity before the start line. We designate a constant force to pull, which is 0.5 Newton. Then we lift the object a little bit with our hand to help our force to exceed static friction force. But we shouldn't pull the object in order to not create an extra pulling force and a V0. Now we will measure the time between start and finish line. We can find the acceleration from the formula using distance and time. And we suppose that the V0 is 0. Then find the net force acting on the object. Subtracting the 0.5 Newton from the net force gives us the kinetic friction force. We can find the kinetic friction coefficients from the formula.